Calculus, we're going to be looking at the derivative of y equals ln x today. Yesterday you made the amazing discovery that if you have a function f at x equals ln x, and we look at the derivative looks strangely like 1 over x, but in the section where x is greater than 0. But that makes sense because f at x equals ln x is only defined for x is greater than 0. So we have this beautiful relationship between ln and its derivative, as we had a beautiful relationship between e to the x and its derivative. So we're going to continue today. I'm going to do some easy ones and make you do some hard ones, but we're going to try some interesting ln functions. So the first one we're going to look at is y equals ln of 5x. So that's technically a chain rule. There's a little function inside the ln function. So if we're looking for the derivative of ln is 1 over. So I have 1 over, but don't forget the guts. So in the end, the slope of the tangents follows 1 over x for ln of 5x, just as it does for ln of x. At x equals 2, I have 1/2 as my slope of the tangent. Our second one is a quotient rule. So if we're doing the quotient rule, we have derivative of the first, which is 1 over x, times the second. Subtract the first derivative of the second, all over the second squared. Now I'm expecting my derivative to be 1 degree smaller than the original function, so I believe there will be a factor of x squared I can take out just to tidy that up a little bit. So I'm going to tidy up the top. It's x squared subtract 3x squared ln x, just get a habit. That's how I order things. And I do see a common factor of x squared. And so if I factor that out, as I imagined, I have ugly over x to the 4. When x equals 4, I have my slope of the tangent is 1 minus 3 ln 4 over 4 to the 4. I need a calculator for that. Slope of the tangent is -0.012. For our third example, sorry I don't have it typed here, y equals ln of ugly. So I want the slope of the tangent at x equals 1, and I have a chain rule. I have ln of a function. So my derivative would be, the derivative of ln is 1 over. And then don't forget the guts. My guts would be 2x plus e to the x, which is a weird sentence, really. Okay, at x equals 1, my slope of the tangent would be 1 over 1 plus e times 2 plus e. So 2 plus e over 1 plus e is approximately 1.269. You might want to check that. All right, last example is y equals ln x over 3x. So I have a quotient rule, and I want to find the slope of the tangent at a specific place. So my derivative would be the derivative of the top times the bottom. Subtract the top derivative of the bottom all over the bottom squared. Let's just tidy that up a little bit. It is 3. I feel like I did something wrong here. Oh yeah, because I didn't write the question down right. All right, let's start again. It's just a tiny little change, but it makes it more interesting. Ln of x squared over 3x. Okay, here we go. Derivative. The derivative of the top is 1 over, don't forget the guts, times the bottom. Subtract the top derivative of the bottom all over the bottom squared. That's more interesting. So just see if we can tidy a little bit before we continue. X's divide out. 6 subtract 3 ln x squared over 9x squared at x equals 1. I have my derivative as 6 subtract 3 ln 1 over 9. Well, ln of 1 is 0, so I end up with 6/9, which is 2/3.